Good afternoon, dear viewers. Today is National Vaccination Day, celebrated every year on 16th of March. I am very fortunate to be speaking to you on vaccination, its history and the relevant vaccination of these days. So, coming to the definition of vaccination as per WHO, vaccination is the administration of agent-specific but safe antigenic components that in vaccinated individuals can induce protective immunity against corresponding infectious agent. Now, vaccination saves 2 to 3 million children each year from deadly childhood diseases like measles, diarrhea, pneumonia. Over 1.5 million people die annually from diseases that can be easily prevented by vaccination. In 2017, 1/4 of all deaths among children has been attributed to pneumonia, diarrhea and measles. This data is as by UNICEF. Now, vaccines now protect more children than ever before, but in 2019, approximately 14 million infants did not receive any vaccines. How unfortunate. Now, first observed on 16th March 1995, National Vaccination Day was celebrated when the first dose of oral polio vaccine was given. In India, the last case of wild polio was reported on 13 January 2011. On 27th March 2014, India was certified as polio-free country by WHO. Mission Indradhanush, launched in December 2014 by Government of India to achieve full immunization coverage for all children and pregnant women, selected as one of the 12 best practices globally. Really a proud moment for us. Now, it is said if you don't know history, then you don't know anything. You are just a leaf that doesn't know it is part of a tree. So, studying history enables us to develop better understanding of the world in which we live. The history of how vaccination started helps us to understand important events and trends in the vaccine research and enables us to develop a much greater appreciation for current events today. Now, coming to the history of diseases and vaccines. Evidence exists that Chinese employed smallpox inoculation. It was called variolation in those days because the smallpox material was taken from the pustules, was used as early as 1000 CE. It was practiced in Africa and Turkey as well before it was spread to Europe and the Americas. In 1545, there was a smallpox epidemic in India. Some 8,000 children died in Goa from smallpox, most likely introduced by the Portuguese. In 1625, there was an early smallpox in North America. In 1657, measles appeared in Boston. John Hull wrote in his diary that disease of measles went through the town, but fortunately, only few deaths were recorded. Sydenham, he is an English doctor. He published in his book called Medical Observations on the History and Cure of Acute Diseases. He was the first to do this documentation successfully and in detail. He also recorded details about the measles infection and distinguished this measles disease from scarlet fever. This was in 1676. In 1770, Edward Jenner, an English doctor, learned from a milkmaid that she believed herself protected from smallpox because she had caught cowpox from a cow. Now, cowpox happened to be a mild disease in cattle that can be contracted by humans via sores on the cow. Dairy workers can have pustules on their hands and the infection can spread to other parts of the body. We know now that the cowpox virus belongs to the orthopox family of viruses that also include monkeypox virus and variola viruses which cause smallpox. Now, Edward Jenner breakthrough was a big thing. In 1796, Jenner inoculated 8-year-old James Phipps with matter from cowpox sore. Now, this is the hand from a milkmaid, Sarah Nelms. This actually pictures are taken from the British Museum. Now, Phipps suffered a local reaction and was sick for few days but made a full recovery. In July 1796, Jenner inoculated Phipps with matter from a fresh human smallpox sore. Phipps remained healthy. Jenner later demonstrated that cowpox matter transferred from one individual to another in a human chain provided protection from smallpox. Now, if this is the journal, this is the paper which was written by Jenner. Of course, there were very few takers for his theory in those days. After Royal Society rejected his report of his achievement, Jenner self-published a pamphlet called An Inquiry into the Causes and Effects of Variole Vaccinae, a disease known by the name of cowpox. Henry Klein, an associate of Jenner living in London, used dried vaccine material provided by Jenner to demonstrate that vaccination with cowpox material prevented future smallpox infection. Now, this is the first laboratory where actually vaccine was made. Now, as you can see in this slide, laboratory workers use autoclave to sterilize chicken broth for growing bacteria. This was the laboratory of Louis Pasteur. Pasteur attenuated or weakened the bacteria for use in the vaccine. He stumbled on the method of attenuation by accident. In his lab, Louis Pasteur was studying fowl cholera by injecting chickens with the live bacteria and recording the fatal progression of the illness. He had instructed an assistant to inject the chicken with the fresh culture bacteria before a holiday. The assistant, however, forgot. When the assistant returned a month later, he carried out Pasteur's wishes. The chicken, when showing mild signs of the disease, all survived. When they were healthy again, Pasteur injected them with fresh bacteria. None of them became ill. This was a revolutionary experiment that was done in those days. Later, Pasteur successfully prevented rabies in 9-year-old Joseph Mister by post-exposure vaccination. This was in 1885. Mister's mother brought the boy who was severely bitten by a rabid dog to Pasteur in the hope of preventing the disease. Pasteur was quite certain that the boy would die from rabies infection if he did nothing to save him. So he began a course of 13 injections, one each day of vaccine made from rabbit nervous system tissue. Each successive injection contained a less attenuated or a stronger virus. Mister never developed rabies and the incident was regarded as a tremendous success. Later in life, Mister worked as a caretaker of Pasteur's tomb at the Institut Pasteur in Paris. Vaccine for Japanese encephalitis. Maurice Hilleman, as you will later know, he is a big name in vaccine research. He helped develop a Japanese encephalitis vaccine to protect American troops in the World War II Pacific Theater of Operations. Later in 1960, polio vaccine was developed by Maurice Hilleman at Merck Industries, and he detected a simian virus in the monkey kidney cells and used it to grow polio virus for Merck's polio vaccine. Hilleman later showed that the simian virus SP40 caused tumors in hamsters. Merck eventually withdrew its polio vaccine from market. By 1963, however, government screening programs began to look for simian viruses in polio virus vaccines. In 1962, Maurice Hilleman and his colleagues developed an attenuated measles vaccine by passaging John Ender's measles virus strain over 80 times through different cell types to attain attenuation. The resulting vaccine, Rubivrex, was given with a dose of gamma globulin antibodies to reduce reactions or side effects. In 1969, rubella vaccine, Meruvex, was licensed. Later, it was replaced by vaccines derived from Stanley Plotkin's RA27/3 strain of rubella virus. What exactly is rubella? Rubella is typically a very mild illness. Its symptoms are low-grade fever, rash, swollen glands. However, if a pregnant woman contracts rubella, especially early in pregnancy, the effects can be devastating. Babies exposed to rubella in utero may suffer deafness, blindness, mental retardation, and other deformities. A devastating rubella pandemic developed during 1962 to 65. In United States, more than 20,000 babies were born with congenital rubella syndromes. Tens of thousands of women suffered miscarriages or elected to have abortion due to rubella infection. The pandemic focused medical researchers' attention on the need for an effective vaccine. In 1976, swine flu vaccine was developed by Maurice Hilleman and other scientists. They met US President Gerald Ford to discuss a vaccine response to an outbreak of swine flu influenza at Fort Dix in New Jersey. Congress committed funds to a nationwide vaccination program. Now coming to Edward Jenner, again These three whom I will be describing now were the pioneers of vaccine development. Edward Jenner is remembered as a pioneer of smallpox vaccination and rightly regarded as father of immunology. Dr. Louis Pasteur, renowned for his discoveries of principles of vaccination, microbial fermentation and pasteurization. And of course, Dr. Maurice Hilleman is remembered as the father of modern vaccinology as he developed nearly 40 vaccines during his lifetime. Now, in 21st century, there is an unparalleled growth in vaccine development. The first decade of 21st century has been the most productive in the history of vaccine development. By the end of 2008, according to the recent unpublished data, the total number of vaccine products, including all formulations combined, had reached a record of over 120, making the first decade of the century the most productive in the history of vaccine development. Hopes remain high that new vaccines will be available to combat malaria, tuberculosis, AIDS and other diseases. Now, over the years, vaccines have played a critical role in reducing the spread of and in some cases totally eliminating the threat of the world's most devastating infectious diseases. Vaccines represent some of the most impactful public health advances seen to date. Today, biopharmaceutical companies are working with stakeholders across the research and developmental ecosystems to develop new ways of preventing and treating illnesses with innovative vaccines. According to a 2020 report by America's pharmaceutical companies, there are currently 258 vaccines in development for the treatment or prevention of disease. Among the vaccines in development are, as you can see, there are around 108 vaccines for cancer, including a therapeutic vaccine for non-small cell lung cancer, which uses messenger RNA to mobilize the patient's own immune system to fight tumors. 125 vaccines for infectious diseases, including a vaccine designed to prevent HIV infection by teaching a patient's immune system to recognize and effectively fight the virus. 14 vaccines for allergies, including the peanut allergy. 2 vaccines for Alzheimer's disease, including one therapeutic vaccine that targets amyloid beta proteins, which is linked to the development of neurological disorder. Additionally, numerous different types of potential vaccines are in development that target COVID-19. Now, how vaccines actually prevent diseases? Now, vaccines contain the same antigen or a part of an antigen that cause diseases. For example, measles vaccine contain measles virus, but the antigen in vaccines are either killed or weakened or attenuated to the point that they themselves do not cause disease. Now, as we clearly know that whenever there is an antigenic challenge, there is a primary response which is mainly composed of IgM immunoglobulins, while in a secondary response which is humongous, there is a predominance of IgG immunoglobulins. Now, how do we design vaccines for active immunization? Vaccine designing is actually dependent upon two main important points. First, which branch of the immune system is getting activated, humoral or cell mediated, and the second factor is development of immunological memory. Like as you can see on the left hand side, while making a dose of Salk polio vaccine, when the first antigenic challenge happened, within first 2 weeks there was an antibody development, and then it ebbed over. Now, but the memory actually developed in maybe after, let's say, 6 months or more. So, this is how these are the important things which one has to remember during vaccine development. Now, we all know that there is two types of immunity. One is an active immunization and a passive immunization. Now, immunity to infectious microorganisms can be achieved either through active or through passive immunization. Now, in each case, immunity can be acquired either by natural processes like, for example, mother to fetus, or by artificial means such as an injection of antibodies or vaccines. Now, these are the ways how we can get a passive immunity, like for example, the natural maternal antibody or a humanized monoclonal antibody or an antitoxin, while for acquiring an active immunity, you need either a natural infection or a vaccine. Of course, vaccines are also of various different types: attenuated, inactivated, cloned microbial antigens, multivalent complexes, toxoid vaccines, and so on. Now, passive immunization actually involves transfer of preformed antibodies. It occurs naturally by transfer of maternal antibodies across the placenta to the developing fetus, like maternal antibodies to diphtheria, tetanus, streptococci, rubella, mumps and poliovirus provide protection to the developing fetus. Now, maternal antibodies present in colostrum also provide passive immunity to the infant or the neonate. The passive immunization can also be achieved by injecting a recipient with a preformed antibody. For example, an injection of horse antiserum neutralizes any tetanus toxin produced by Clostridium tetani in the wound. Now, these are the common agents that are used for passive immunization. For example, I will just restrict myself to the snake bite. When a person has a snake bite, then he is being administered horse anti-venin, which protects that person from the deleterious effect of the venom which is produced by the snake. Now, how a commercial anti-venom vaccine production takes place? It is in this way. In a serpentarium, the venom preparation is taken from the venom is prepared or acquired from the snake. This venom is injected into a horse. Hyperimmune plasma or serum is taken up from procured from the horse, and then it is processed. The antibody purification takes place, and these antibodies are finally converted into a product or a formulation which is a ready formulation or an anti-venom formulation which can be used as a therapeutic vaccine whenever there is a snake bite. Now, the active immunization elicits a long-term protection. Whenever it is done, a subsequent exposure to the pathogenic agent will elicit a heightened immune response that successfully eliminates the pathogen or prevents disease. Active immunization can also be achieved by natural infection with a microorganism, or it can be acquired artificially by administration of a vaccine. In active immunization, the immune system plays a big role. There is a proliferation of antigen reactive T and B cells that result in formation of memory cells. Now, vaccination of children begin at the age of 2 months. The recommended program of childhood immunization include mainly the following vaccine: hepatitis B vaccine, TPT, that is diphtheria, pertussis, tetanus combined vaccine, inactivated Salk polio vaccine, IPV or OPV, that is Sabin vaccine, MMR, that is measles, mumps, rubella combined vaccine, Hib vaccine, Haemophilus influenza vaccine, varicella zoster vaccine, pneumococcal conjugate vaccine, that is PCV vaccine. Now, how exactly vaccine work? This is just to show how actually vaccine achieve what it is supposed to be having. Like for example, from this slide you can see in 1975, before vaccination there were more than 23,000 cases, but immediately after 1 year the cases just vanished. There is a 100% reduction of smallpox in the people. So, within a year after vaccination there was a complete eradication of smallpox. Now, the sequential stages of vaccine trial involves a lot many trials. Once a product has been identified, there is a phase 1 trial, there is a phase 2 trial, there is a phase 3 trial. Eventually, right from a product being identified and then being marketed, there can be almost about 10 years time gap where there are so many trials which takes place. Now, the various types of vaccines that are present can be live attenuated vaccine, the chimeric live attenuated vaccine, inactivated vaccine or killed vaccine, subunit vaccine, nucleic acid based vaccine. Now, if we are talking about an whole organism vaccines, there can be two types, like a whole inactivated or a live attenuated. Now, inactivation of the pathogen can be achieved by heating or by chemical means so that it is no longer capable of replication in the host. While in a live attenuation, this can be achieved by growing a pathogenic bacterium or virus for a prolonged period under abnormal culture conditions. Now, when talking about a whole organism vaccine, there is a capacity for transient growth within the injected host. Prolonged immune system exposure is there to the individual epitopes on the attenuated organism, that results in increased immunogenicity. It is required in a single dose and it induces a cell mediated and humoral response. Example being the Sabin vaccine, OPV, oral polio vaccine, or the Bacillus calmette-guerin vaccine, that is the BCG vaccine. However, there is a major disadvantage to this attenuated vaccine, that there is a possibility that they can revert to a virulent form. Now, coming to the next, which is the BCG immunity and tuberculosis vaccine. The BCG vaccine for percutaneous use is an attenuated live culture preparation of BCG strain of Mycobacterium bovis. It was developed by growing M. bovis on a medium containing increasing concentration of bile. Tuberculosis is primarily an airborne communicable disease due to a bacterium called Mycobacterium tuberculosis. Now, the typhoid vaccine is again another similar type of a vaccine. The Vivotif, which is a typhoid vaccine, it's a live oral T521A vaccine which is used for oral administration. Each entry coated capsule contains not less than 2 into 10⁹ viable organisms. Now, how the polio vaccine was developed in Vienna, Karl-Heinz Steiner and Erwin Popper in 1908 announced that the infectious agent in polio was a virus. They actually did an experiment where what they did was they carefully filtered preparation of spinal cord fluid. The filters were known to trap the bacteria. They used the preparation and injected in the filtered preparation and injected into monkeys, and the monkeys were later found to be protected from the polio. The researchers then concluded that an infectious particle which is smaller than bacteria caused the disease. Polio virus itself was not visible to researchers until 1950 when the electron microscope became available. Now, Sabin was convinced that the polio virus lived primarily in the intestines. Sabin focused on isolating a mutant form of the polio virus which was capable of producing the disease and thereby safe for introduction to human body. The avirulent virus would reproduce rapidly in the intestines, displacing the lethal form of polio virus and providing protection from the disease. Currently, the Sabin polio vaccine consists of 3 attenuated strains of polio virus that is administered orally to children on a sugar cube or in a sugar liquid. Now, as we progress towards the worldwide eradication of polio, you can see in India it is still in orange color, that is there are still more than 10 cases of polio, right. Now, these are some of the pictures you might have seen in 2014 in the newspaper. Little drops that make a big impact on the world. This was a polio eradication program in India. With the global initiative of eradication of polio in 1988, following World Health Assembly resolution, pulse polio immunization started in 1995. Due to this initiative, you must have seen all these people, these pictures of people having yellow jackets and administering polio drops in India. Now, the children in the age group of 0 to 5 years were administered polio drops during national and sub-national immunization rounds. About 172 million children were immunized during each national immunization day. The last polio case in the country was reported from Hara in West Bengal on 13 January 2011. Thereafter, no polio cases has been reported in the country. There are 0 polio cases since January 2014. Congratulations India, this was the UNICEF picture in 2014, because prior to this 3 years there was not a single reported case of polio. India was declared polio free in January 2014 after 3 years of 0 cases, an achievement widely believed to have been spurred by the successful pulse polio campaign in which all children were administered polio drops. Now, I just want to quote this quote by the Director General of WHO that vaccines are one of the most important tools for preventing outbreaks and keeping the world safe. While most children today are being vaccinated, far too many are left behind. Unacceptably, it's often those who are most at risk, the poorest, the most marginalized, those touched by conflict or forced from their homes, who are persistently missed. So, on National Immunization Day, let us pledge not to miss any of your child's vaccination and let us spread awareness to eradicate disease. Let us try to make the world a better place. Thank you very much.